Thanks everyone for joining. So we amended the title of our session a little bit, and you will see why throughout the talk actually. So we are here to talk about one import surface to RuleSML. So you will see why we make the distinction. My name is Florent. I work at Neo4j in the connectors team. Ali?
Yeah, I'm Ali, and I'm also working on the connectors team.
All right. And so our mission in the connectors team is basically to make data movement from Neo4j as smooth as possible, and also to make sure that it's available wherever you are, regardless of the cloud provider, if you're on-prem, etc., etc. So that's really a big part of our mission. And you will see that what we're talking about here today is really, into that frame, really, into that frame of work. And so what we're going to talk about is actually called import spec. So that's an import surface for import payloads, import jobs, really. So we're going to talk about that first, like how it came to be, what it is, what are the concepts related to that. Then we'll actually spend a big chunk of our time today together to demo it. So first by creating a simple spec, and then seeing the spec being leveraged in two very different runtime environments. One of them being Neo4j admin, that you might know as a CLI to do offline or incremental imports. The other one being an Apache Beam pipeline, Apache Beam being a framework that unifies streaming and non-streaming data pipelines. And so, yeah, let's talk about import spec. But the first important bit is, why do we even talk about it today? And so we started, we work in the connectors team, so we are quite aware of the landscape in general to move data from Neo4j or to Neo4j. And so this table here is far from being exhaustive, but it shows just a few possible solutions. The criteria, to pick, to decide which one to use is a bit out of scope, so I'm not going to go through that. But for instance, we have Neo4j admin, as I mentioned earlier, which is a CLI which allows you to import CSV data and maybe soon Parquet files as well. It supports offline, so you can pre-create data store files and then stand up the database afterwards. It also supports incremental online imports as well. We have our Apache Kafka connector, which is not only for initial data imports, of course, but it can be used for that purpose. Same thing with Spark, really. And in that case, you have many different input formats, in both cases for Kafka and Spark. And you can write to Neo4j as well, thanks to our connectors. They do not support offline. Actually, only Neo4j admin supports offline imports. And so Neo4j admin is a CLI, Kafka and Spark, you will have to write a program for it. So maybe in a notebook for Spark, or maybe through a regular program. Neo4j data importer, as you might know, is a graphical user interface that allows you to select CSV sources and map them to a graph and then run the import in the browser. So that does not support offline, but that supports online imports. And then another connector our team is working on, like Kafka and Spark, is a Neo4j template for Google Cloud Dataflow, which supports BigQuery sources and CSV sources at the moment, does not support offline, is incremental. And in that case, this one is declarative. And it's because it's a Google Cloud product, it can be accessed through a graphical user interface if you want, command line or API. And actually, in 2 hours from now, I will have a talk on this project in particular. And the reason it's declarative is because it uses import spec, actually, to define how you want to import your data. So you define where the data comes from, how you map it to the graph. But we'll talk about this in much greater detail in a few seconds. And so, again, there are many more tools out there to perform data imports in some ways. But that's the thing, right? We have many tools, but they all have a different configuration surface. But when you think about it from a high enough level, from a high enough distance, the purpose is more or less the same, right? It's initialize the database schema maybe, so Neo4j supports indices and constraints. Then fetch data from sources, and somehow maps these pieces of data to nodes and relationships, right? That's the end goal, right? It has to have your database populated with consistent data and while making sure the data integrity is not at risk. So they all fulfill that purpose in a way. And so we were thinking, what if there was a way to actually have a uniform configuration surface? Like, because the goal, again, there is a very common goal here for all these tools. And that's how import spec came to be. And so, yeah, let's dive into it a little more now. So as I said, it's a uniform configuration surface. And as you will see in the demo, we'll have a single spec, and yet it will run in two completely different environments. It's also an extensible JVM library. So you have the configuration schema that is available regardless of your runtime, really. Then you also have a Java library that allows you basically to get access to the configuration as a Java class. And there is a plugin system, so you can define your own data sources. And you also can add extra constraints. So the schema, make sure there are some basics on what the combination can be. So there is that in place, of course, with the JSON schema we use. We also have some more semantic validations built in, but obviously, depending on the runtime, you might have extra constraints or restrictions, and that's why there is a plugin system for that too. One of the key points, as we said earlier, also it's not tied to a specific runtime. It's not tied to Kafka, Spark, Dataflow, etc. Right? It's really about what does the import looks like? What are my sources? How do I map that to a graph? And finally, it's also not tied to the deployment topology of Neo4j, whether it's single instance or a cluster. Is it Aura specific or not? That is out of scope of import spec. So enough talk now. Let's dive into the concepts. So we have sources, as I said. So we have what's important really is the mapping part, right? You have data sources, which are, again, a plugin system. So you define your own sources, which will basically expose batches of records. And then those records will be mapped to either a node target or a relationship target. So node target will describe the shape of a node you want in your graph. So that's why you will have attributes like labels. Which labels should this specific node shape have? It will have property mappings, just like relationships, which will tell, okay, I'm taking these fields from this source, and I'm naming them this way for properties. So we'll have this field to property mapping going on. That is part of the target definition for node targets and relationship targets. And then you also have schema description, so your indices and constraints you have for this particular node or relationship. So I mentioned labels for node targets. Obviously, you also have type for relationship. And then you can control a few more things, like do you want to create the node every time there is a record to consume, or do you want to merge it? Same thing for relationships. And for relationships, you have a second level, which is how do you want to deal with the start and end nodes, right? Because a relationship is between two nodes. So that's why a relationship target has also two references, one for the start node, one for the end node, so references to the corresponding targets. And you can tell whether you want to match those nodes or merge. And finally, if the declarative aspect of these two target types are too restrictive, there is always the escape hatch that we call query target, which is quite simple. It takes data from a source as well, just like the other targets. But then there is no declarative mapping. It's just a custom Cypher query, and then you write anything you need. And based on that, you're basically free to do whatever you want. If your target server has APOC, for instance, you can run call some APOC procedures or functions in there and initialize the graph as any way you see fit. And so once you've got those targets in place, so your mapping logic is declared, then you will basically dump this to a Neo4j database. How that Neo4j database so how its location is encoded is actually not part of import spec. Import spec really is a blue and green parts. So basically the source, targets, and actions part. Where the Neo4j, how the Neo4j is located is basically not in the import spec scope. And so, as I just mentioned, we also have actions. So targets basically consume batches of records from sources typically, whereas actions are just one of, how can I say, scripts almost, one of actions. Sorry, one of actions. I can't think of a better word. One of actions to run at a different stage of the pipeline. So that's why they also have a stage attribute. You have HTTP, so you will get URL method headers, even though we're currently restricted to get and post. You have the Cypher action. So HTTP action will talk to an IP3 server. Cypher action will talk to the implicit Neo4j database target. You can give a query and whether you want explicit transactions or not. And then we also have BigQuery action, which talk to a BigQuery target and run a query. Very similar to Cypher, but just targeting a BigQuery instance instead. That being said, we'll maybe review these action things. Maybe we'll only keep the Cypher action by default and have a plugin system for the rest. That's something we will discuss later within the team. And finally, an example. So this is a very simple spec in YAML this time. We support YAML and JSON. So you will need a version. The version is currently 1. You need to declare at least one sources. In that case, you declare a BigQuery source, but you also need to provide it through the plugin system. And you have a simple query, which selects 2 fields from a specific BigQuery table, which is all nice and dandy. But then that source must be bound to at least one target. And here, to keep things simple, we declare the custom Cypher query target with a name. So all names are unique within the pipeline related to a source. So the source we defined above. And then in that case, we have a convention that obviously depends on the implementation you choose to write for your import spec backend. But in that case, you can assume that this $rows is the current batch of data and is predefined. So that way, that query will be executed as many times as there are batches of data from the source to consume. And what we'll do, we'll iterate over each row. And for each row, we'll create a node with a simple label and then the attributes that are a part of that row. And that's basically the simplest, import we could define with the spec. And the JSON variant is basically just the same, but in JSON. But yeah, let's dive into it a little more. And here, I will let Ali take over and talk about the demo setup and admin import. So up to you, Ali. I will stop sharing as well.
Is the screen visible?
Yep, all good.
Okay, great. So for the demo part, what we're going to do is we will run an import of the DVD rental dataset, also known as Sakila, that comes with MySQL sample databases. And a partial of that, actually. We are not focused on the whole tables to keep it simple. And we will run the import using Neo4j admin import backend and also with an Apache Beam backend using the same spec. So let's look into the data structure first. We have films and categories. Each film may have multiple categories linked through a film category relational table. And we also have actors, and we have a relationship between film and actors as well. And also we have customers which or who runs films, but this rental is represented in a two-hop. So we have a rental table that links a customer to an inventory, and inventory actually links to films to stores. But since we are not importing stores, this inventory is kind of a link table which we will delete with a Cypher action. And From this structure, we want to reach to this graph model. So we will have movies with 4 properties, and with categories, basically an ID and a name, and movie can have multiple categories. And we will have actors with ID, first name and last name, and link them to the movies they acted in. And we will have customers with their rentals represented relationships. So, not conclusion. I will now switch over to a YAML file, and we will basically start creating one import spec, a small part of it actually. So we have this now. I will just pass a processing statement to tell Visual Studio Code where to find the schema. This will be published eventually to a publicly accessible place, but currently it's on my local. So with this, we have autocomplete. And let's go to version. Then we need to define our sources. And sources, as Florent already mentioned, is extensible. And the import spec doesn't define any source itself. And here, what we want to showcase is importing from a set of Parquet files. So I'll pick Parquet as a source type, and we'll name it as category. Now I need to define, more Parquet specific things. So this is where our extensibility feature comes in. Here in our code, we actually define the Parquet source provider, and this allows us to define Parquet sources with a URI. So we actually only expect an additional new URI property on the sources. And the way this is picked up by the import spec library is through service loader mechanism in Java. So you declare your source providers as resource files, and this is picked automatically. So let's go back to Visual Studio Code, and we need our URI here, which is in GCS bucket. And I will just add this one, category.parquet. And I will add 2 more sources. Let me just copy them and paste here. And I have the categories, I have the films, and I have the film category relationship files. Now, what I will do is I will declare my targets, and I will have 2 set of nodes, basically. First is category. It is sourced from the category Parquet file in this case. And let's name it as category nodes. And labels would be category. And write mode, we say it will merge. So the generated cyber statement will be merge instead of create. And we then map properties from this source file into the node. So I have the category ID source field, and I want this to be named as ID. And this is of type integer. And I have another source field, which is name. I don't change the name of this, and this is a string type. And I will go and add the film as well through copying. Here we declare the new film target node. It's named as movie nodes. We again merge them. Labels, it is labeled as movie, and we have 4 properties that are mapped from source to target. And what we also require is some key constraint. And here we say, okay, for the category, we have a key constraint. Let's say category ID key. It is on label category, and the property is ID. That's the target property that we map to. And for the film, it will be key constraints. Let's see, movie ID key. The label will be movie, and again, property is ID. So this is the part that we define the nodes, and I will also show a relationship. And let's go relationship, and this is in category, is named. It is sourced from film category, name as movie category relationships, and we just reference the start node and end node that we have already defined. And what is it complaining about? Only I must start at the same column. Yeah, so probably I have an indentation problem. Yeah. I think that's all I want to live code. What I have here is a completed version of this. Declared all the sources with the all set of nodes. Also defined unique constraints and type constraints, which you can add. And finally, we have the relationships, all of them, and final cipher action that gets rid of the inventory nodes and turns them into a granted relationship. So with that, how the code looks like. This is all our demos are implemented as a test case. And since the Neo4j admin database import from Parquet file is an unreleased feature, we are using a pre-release Docker image. So if you want to try it on, that won't be possible with the current latest 5.25 Neo4j. It will be upcoming in the future, please. And in a nutshell, what we do is we read the spec and deserialize it and construct an Neo4j admin utility. We do a few transformations because of a couple of features that are not yet implemented. One is the header mapping, so we need to change the header names in each Parquet file. And thanks to DuckDB, that's super convenient and easy to do. And after doing this shuffling, we basically execute the import itself. And import, as we build an Neo4j admin database import full command line from our specification. And once that is completed, we you might recall that admin import is an offline import mechanism, so it generates the database files. So we need to create a database out of that. And we run our post actions. And since the Parquet admin import Parquet feature does not support native Parquet types, we do a temporal property migration. So we convert them from integers to actual temporal types. And finally, we execute our schema statements. So this is how it looks like. I don't want to go in too much detail for the sake of time. So let's give it a try. And finally, like after this, we have assertion set where it asserts number of nodes and relationships. And we expect this to go green if we are lucky, because we are aware of a problem in this pre-release state feature. So sometimes it fails, but that's obviously that won't be the case when this is released. And yeah, well, that's green, and we have imported and we have asserted all these nodes and relationships are imported. So that's all I will show about the admin import part. Now I'm handing it over back to Florent for him to show the beam parts.
Thank you. And here we go. So entire screen. And so yeah, I'm gonna be quick. And the reason I can be quick is because Ali did all the work. It's the same spec as before, you know, all the same things. The test obviously is going to be a little different because we're using Apache Beam in that case. I mean, we still have a Neo4j target, so just a regular container system with your regular release. We're using test pipeline, which is a way to run import pipelines in Beam just in a test. But then the assertion, so I'm starting with the end of the test. I know it's a bit strange, but if we scroll down, you will see at the end that we do the same assertions as before, right? So the assertions, the checks are the same. The source plugin implementation is the same. We also have this Parquet source. And so I'm going to go very quick over the Beam details because, again, it's not a Beam presentation, really. So we deserialize the spec. Then we lazily fetch the target, the source outputs, and we track them. That way, when we process targets, so for each target, we'll go through, find the corresponding source, and init the schema. So that's something happening here. We have the source that we parse here lazily, and then we apply on the source records we got. We'll first make sure that the source schema init has run. So that's why you have dependencies with the schema init as well. So if you have key constraints, unique constraint indices and whatnot. And once that's done, here we do a very simple batching logic, which is again not very realistic in terms of production because we do batches of 50, which is very low. So don't do a batching blindly like this. It's just, again, for the sake of illustration. And then finally, we write each batch to Neo4j. I'm not going to go through the implementation. We also have actions. In that case, we basically implemented only the subset we wanted. That is cipher actions running at the end. Basically means they depend on all the targets being done. And we just run them, so basically run their query. And I'm gonna just run the tests. It should pass, hopefully, as well. And then I will conclude with the little time we have left. And it should just pass, hopefully. So let me move that a bit up. And yeah, I mean, the clock is ticking. We have a few seconds, so hopefully enough. The data set is not really big, so it shouldn't take too long. Oh man, too much suspense, it's killing me. I'm gonna jump to the conclusion. If I have a few seconds left, then I will go check the result. So yeah, it's still early days for this project, but we're really keen to hear your feedback. We are thinking of a few improvements, like having a nicer API for pipeline execution. We've been writing these examples in a few different contexts, and we've seen some potential rooms for improvement. As I mentioned earlier, maybe we'll make actions pluggable with a default cipher action, but the rest will be plugins. Then there is a few other improvement, maybe a graphical user interface in the future, who knows. And if I check real quick, yes, the test has passed, and I think it's time. So thank you very much, everyone. And yeah, if you have questions, you know how to reach out to us. We are Florent and Ali at Neo4j. Thanks a lot.
Thank you for listening. Bye.